In this video, we shall explain how to access elements of the vectors in R. Usually, in programming languages such as C, C++, etc., indexes of the elements are given inside the square brackets. This is also valid in R also. However, here we have lot more flexibility. We can select a group of elements, which is normally called as subsetting. In fact, in scientific computations, we require a subsection of a vector or a matrix. So this is really abstracted in R language. Also, in C, C++, etc., element indexes has to be integers, whereas in R it supports even names also, that is strings also. These things we shall try to understand in this video. Unlike other programming languages such as C, C++, Java, etc., here in R, first element index is 1. If x is a vector, then x square brackets 3 indicates or returns third element of that vector x. Here, x is a vector having all natural numbers 1 to 20. X square brackets 5:7 closing square brackets refers to the elements of x starting from 5th element to 7th element. This is a subsetting. That is, we are selecting a subvector of the vector x. This is called as subsetting. The command x of -3 displays elements other than third element of the vector x. We cannot give more than one element index inside the square brackets. That is, x inside the square brackets 3, 3, 8 is not a valid statement. This command x inside square brackets C 3, 3, 8 will select third element of x, again third element of x, and 8th element of x. Like this, we can specify the indexes of the elements which we wanted inside the square brackets using C function. That is, we can specify the indexes of the elements which we wanted as a vector inside the square brackets. This is acceptable. In the same fashion, this command selects 8th element, third element, and again third element of the vector x. This command selects elements other than third element, 7th element, and 2nd element of the vector x. This command also works like previous command. That is, this also selects elements other than third, 7th, and 2nd elements of the vector x. As mentioned above, that inside the square brackets we can give a vector, that is, the indexes of the elements which we wanted we can specify as a vector. However, they have to be either all positive numbers or all negative numbers. Anything other than this is not acceptable. Thus, this command gives error. This command selects all elements other than first 6 elements. This command displays second, third, fourth, fifth, sixth, 10th, 13th, 14th, 15th and 16th elements of the vector x. Like this also we can specify what elements we wanted inside the square brackets. That is, we need to supply their indexes. They are not necessarily in any order. They can be in any order. They can be repeated also. Not a problem. However, one important aspect is all the indexes has to be either positive or negative. We can also give a logical vector as argument to the square brackets. That is, we can use a logical vector inside the square brackets along with a vector type of object. If we do so, the elements wherever true is there, that respective element of the vector is displayed. Do remember that if the vector which we are supplying logical vector, its size is not same as the size of the vector x, then simply the logical vector elements will be recycled. I am sure you remember this concept. Like this, for example here, x greater than 10 gives a logical vector. Wherever that condition is true, the result is true. Whereas, wherever the condition is false, the result is false. So thus we are getting a logical vector with false and true. So that we are supplying to square brackets. Thus, x inside the square bracket x greater than 10 simply selects those elements of x whose value is more than 10. This command displays 20th element, 19th element, 18th element, etc. till 15th element of x. That is, we can specify the sequence in descending order also. It is acceptable. This selects elements other than 15th to 20th elements. This command displays indexes of the elements whose values are same as maximum of the vector x. This is how which command can be used. That is, which command displays indexes for which that condition is satisfying. This command displays the largest elements of x. We know that which command returns the indexes of the vector x which contains the largest value of x. They are being sent to x. Thus, that respective elements will be displayed. These two commands displays the second largest value of x. How this is possible? The which command returns the indexes of the largest values of x. Then we select other than those things and send them to max function again, which returns the maximum of those elements which are other than the largest elements. That becomes the second largest element. This command displays largest and second largest of vector x. This command is little tricky to understand. X of 1 is to 10 selects first 10 elements of X. From that, second, third, fourth, fifth elements will be selected. From that, third and second elements will be selected. Like this, we can subset to any level. This is to explain what's meant by subsetting, or rather say nested subsetting. You can verify. In fact, we have shown that what you will get if I do X of 1 is to 10 only, then followed by 2 is to 5, then further third 3 is to 2 is added. We have shown the results step by step fashion also for the sake of understanding. This is also little tricky to understand. First we go to the innermost one, X of 1, the first element of X, that is 1. That will be again X of 1, again 1, X of 1. Effectively, we will be getting 1. It all depends. For example, the first element value is 7. Then, first X of 1 gives you 7. X of 7, if the value is 10, then X of 10. So, the 10th element value you will be getting. Like this, one has to understand the trickier concept of subsetting. As mentioned in the beginning of this lesson, that we can use strings, also indexes of the vector. So here we are specifying for each element some strings. There we are calling them as names. Now X of 2 gives me the element whose name is 2. X of 3, it gives me the element value of X whose respective name is 3. Like this, we can use names or strings as indexes rather to access the elements of the vector. Of course, we can specify a group of names inside a C function, and also we can access those elements whose names are matching with these elements of the vector C. However, we cannot use the concept of minus here. That is, we cannot select the elements whose names are other than the given name. Like this, it is not possible. Consider a small practical example. Assume that we have two vectors. In one vector marks, we have student marks, and another vector IDs, we have student identification numbers. I wanted the identification numbers of the students who are passed. Of course, we assume pass mark is 35. This command will display the IDs of those students who are passed. This command displays IDs of the students whose marks are in between 50 to 60, that is second class. Incidentally, 56 is the only one which satisfies this condition. The respective ID is 110, that is displayed here. This command tries to display the IDs of the students who got highest marks. For the purpose of demonstration, we have changed both marks and IDs, and this command displays IDs of the students whose marks are highest. Try to understand the working of this command. Why it is giving 105, 106, 115 as the result. Of course, respective marks you can verify. In this video, we have explained how to access elements of the vectors, also subsetting, how can you select a subset of a vector, a section of a vector, or maybe a group of elements, or randomly some number of elements, or other than some elements of the vector. Also how to select based upon strings as indexes. These concepts are explained in this video. I hope you understood the concepts. If you like, please kindly ask your friends to subscribe to my channel. Thank you.